Our trainer will be Rahul. And before we get started, I would like to cover just a few points here. So as you've noticed, everyone is muted. That's to help make sure we have as clean as possible recording for everybody, because we are recording this session. And anybody that did sign up for this session will be sent an email with the link to this recording. And that way you can review it again at a later time, or send it to other people on your team who weren't able to watch this session. If you do have any questions while the session is going on, please use the question tab. Type it in there. I'll be moderating that too. And if need be, I'll stop the trainer and have him answer the question at that time, or we'll wait till the end of the session where we'll have at least 10 minutes set aside to answer any questions that you might have. Also, at the end, we'll have two really short questions that we would like to ask you to fill out. They basically have to do to find out if there's any other preferred time to do these sessions, and also to find out if you'd like us to contact you and your team for more detailed session. Again, that's meant to be for your team or department, not a one-on-one session though. One of the questions that has come up in each of these is there a student version available of our software? And the answer is yes. We do have a student version available of HyperWorks for our students, and I'm just going to go and show where you can find it. So if you go to the link that I had on the PowerPoint, or if you just go to our normal web site and go to the Academia tab, it'll take you to our Altair University area. And in here, you can see this is where we have the free student version. Once you pick on that, you will have to order a copy. Now it's free, but that's a terminology used is ordering. And then once you fill out the order form, you'll get an email, some additional information in it, and
Hey Darius.
It sounds like we've lost. It sounds like we've lost the audio. Okay.
So, hello everyone. I hope you can hear me, and if you can't, if you're having any audio problems, just use the chat window to let us know.
I can hear you.
Right. So, I guess we'll start with the presentation for today, and I want to start with the traditional design process that we use when we're designing anything. And you could call this the simulation-driven design process, where you start with your CAD design. So it doesn't matter what you're designing. So you generally start with a particular shape, which you generate using your CAD, and you then use CAE to build a model, and then you verify its performance, and if it's not satisfactory, you go back to your CAD tool. And this is the iteration that we follow, and I think the question is, how efficient is this approach? And fact is, you can improve the traditional design process with what we call an optimization-driven design process, where you start with concept optimization, and that gives you the initial CAD design to take forward and then verify the performance of which. So the idea is to start with the best possible design, rather than to start with a particular shape. You verify the performance and then tweak it here and there. So if you take the example of a bracket and you want to reduce the weight, so you don't know where to start generally, especially if it's because it is a three-dimensional model, and you don't know if you have to drill holes or where you're going to drill the holes, if you're going to cut off the corners, or exactly where will you remove the material to make it function as you want it to, and also reduce weight. So Inspire helps you do exactly that. It helps you start with the optimal design shape. And when you're designing with Inspire, there are a couple of ways you can go about it. So you can start by, you will start with a blank design space with as much volume as you can give to the tool, and then Inspire gives you a shape that you can take to manufacture directly. Or what you might like to do is, once Inspire generates a concept shape, you would then verify its performance, and you would maybe run a linear static analysis, for example, to see how strong the shape generated by Inspire is. And when you're satisfied, you then take it to manufacturing or when you're actually doing your linear static analysis on the concept shape generated by Inspire, you might find that the displacements are not very high, or you've been very conservative with your constraints and your initial inputs to Inspire when you were generating your concept. So then you would want to go back to Inspire, maybe give a more aggressive input so that you remove more mass and you still don't compromise on performance, and then you go to manufacturing with a much better shape. So that's briefly about the optimization-driven design process and certain ideas of how you would go about using Inspire when you're designing your components for your car. So I think I'll start with the GUI.
I want to interrupt you for 1 second. One individual mentioned they couldn't hear you, so I just want to double check with others. Please let me know if you can hear us speaking right now. So if someone can put in a chat window, yes, okay, so good, that's what I wanted to see. Thank you. Good, so please continue on. Thank you.
Right, thank you. So, so this is Inspire 2014. So you start Inspire the usual way. It usually is installed in your Windows machine as Inspire 2014 3969. You just go and click Inspire, and this is the icon for Inspire. So this would then bring up the screen, and the Inspire GUI is very simple and easy to use. So you would start with the file open and new model and save icons. So this is what you use to bring in your model from CAD. So let's say you have a CAD tool and you are comfortable with using your CAD tool to design your models. So you would probably use CATIA or SolidWorks, and Inspire can directly import these formats. And for example, I have a Parasolid here. So Inspire, it's as easy as just going to open model, choosing your file, and I just want to point out that most of your CAD formats are supported, so you can go ahead using your existing CAD tool to create your model. So if you don't want to use your CAD tool, and if you want to use Inspire to create your sketch and your design space, as we call it, it's possible, and it's very easy to do that with Inspire. So how Inspire works is it gives you a series of tools to first draw a 2D sketch. So you see you have options to draw lines and points, rectangles, many ways to draw your rectangle and circles and arcs, just about everything necessary to create your 2D sketch of your model. And you have two tools here. Excuse me. So you have these two tools which we call trim and break. So this is used while you're sketching and to modify your 2D sketch. And once your 2D sketch is done, it's just as easy as pushing it or pulling it to create a 3D sketch out of it. And then that becomes a solid, and you then have a set of tools which helps you edit the solid model. And the simplified patch set of tools is is I think more for editing geometry from CAD, because you might want to, you might have some lines or some duplicate surfaces or surfaces missing in your model when you bring it in from CAD, and you want to quickly repair that. So you can do that with simplify and patch. So once you've got your model ready, you would then assign materials, and you can also create mass entities for components that you don't want to exactly model, but you want their mass to be taken into effect during optimization. So you would then use the parts tools for that. And you then would want to apply shape controls, because you want to make sure the shape generated by Inspire is actually manufacturable. So you have a set of tools that helps you, given certain inputs, like you can say, I'm going to extrude this part, so then Inspire gives you a shape that's of constant cross section. Or you can say, I'm going to cast it, and Inspire would then try and give you, Inspire will give you a shape that can be cast, and you can give it inputs about how you're going to remove the mold from the model. And once you've given such manufacturing constraints, you need to apply the all-important loads, and you need to constrain your model, and that's done using the loads and supports tool set. And you're then ready to either analyze, which will run a linear static analysis and give you results directly, or you would optimize, which is really our main goal with Inspire, where we try and find the optimal solution for our boundary conditions and constraints. So you then have a few tools that are very useful. For example, you want to measure an existing model, maybe designed by somebody else, and you want to know the dimensions, or you want to measure the mass before and after optimization. So you do that with the measure tools. You would generally want to move around certain components, fix them, and rotate them, and you can do that with the translate or the rotate set of tools. You have the standard views function here, which helps you look at your model at, from different perspectives, and there's more than one way to do that. You could also use your coordinate system here, and show hide is basically to hide certain components and show only those that are relevant. And configure is very interesting. It actually helps you quickly try out various combinations, because it's almost as if you're removing certain components from the workspace, but it's still in the background. So that's how configure helps you. So it's just I just wanted to give you a brief introduction into what the tools are, and we're going to look at each one in detail, and we're going to actually use all these tools, well, most of these tools, to try and design a bracket right now. So let's just go ahead and do that. So I'm going to start by saying this is a new model. So I just click on the new model icon and make sure there's nothing on my workspace right now. And this is what we call the model browser, and this is the property editor. And you'll see what they mean and how they're useful as we go along. So for my particular design, I'm going to sketch using Inspire. So I'm going to start with lines. So when I'm sketching, and the first question that comes to my mind is, what are my units? What are the units I'm going to use for my sketch and for my model? So you see, it's currently in meters, and that's because Inspire for me has been set for meters, kg, newtons, and pascals. This is the SI unit system, and it's very easy to change it. You can just change it to imperial standard this way. And so I'm just gonna Control Z so I can go back to where I was. So that's one of the cool features of Inspire. You can make mistakes and go back very easily. You just Control Z. So I'm currently in the inches pounds system, and I'm gonna draw a line. So you would notice as soon as I click on lines, there's a sketch plane that's being created for me, and I've got grids that helps me sketch. So this will be 1 inch, and you see that it displays the dimension and the units here. And when I'm doing that, actually a cool feature is I could actually say I want this to be 5.08 centimeters, and I press enter, and it automatically converts it into inches. So if you've got your plans already laid out in another unit system, no problem. You just type it in, the units that you already know, and you can still create a sketch in another system of units. So I'm just going to Control Z again. So I have a 1 inch line, and I'm just going to continue sketching this way. So every time I finish sketching a line, it gives me a field where I can just change the dimension. So which is very easy, and it's easy for me to sketch very quickly and accurately this way. So by actually creating a 2D sketch of a bracket that is a general design that's useful in any structure, where you're going to try and connect two structures with 3 bolt holes, for example. So this is my design, and my 2D sketch. And so once I'm done, I right-click in the workspace, and I right-click outside, and I immediately exit the lines function. So when you're using the function, you see it's highlighted in yellow, and I just right-click, and I'm outside. The sketch area, I right-click, and I exit the function. So this is common with all functions in Inspire. You just right-click, and you exit that function. So I right-click again, and Inspire immediately recognizes that this is a closed 2D sketch, and it completes it and creates a surface out of it. And it also understands that the next thing we want to do is extrude this and create a 2D sketch. So it automatically goes to the next function, which is push-pull. So just to see, just to illustrate again, so you see push-pull is not activated, but I just right-click. So Inspire creates a surface and activates push-pull. So now I'm just going to rate it a little bit so that it's easy for me to see what I'm doing. And now I'm just holding the surface with the left click of my mouse, and I'm just now pushing it and pulling it. And it's really that easy to create a 2D model, and I'm able to pull it up to 2 inches, which is what I want. So I just press F on my keyboard and it fits the model into the workspace, and I can also move it around with these arrows around the coordinate system. So this is my blank 2D sketch of my bracket, and now what I want to do is I want to create a few holes in this solid and fill it up, create bosses. So I want to create a hole, and it's very easy, and it's actually really cool how Inspire helps you do that. So I want to create a hole in this area here, so I just click on the surface, and that automatically Inspire creates a sketch plane on that surface. So I'm currently using the circle with a center and radius option. So I just click here, and that's the center of my circle, and I just move it around to get a circle of the radius that I want. And just like with our initial sketching and the push-pull, Inspire always gives you a field to modify your sketch. So again, I right-click to exit, right-click again, and once again we're in the push-pull mode automatically, and it's as easy as pushing it out to create a circle. So you use push-pull not just to create solids, but also remove material from your solid to create the shapes that you want. So once again, I need to create a circle here because I want holes there, and I just right-click out, and I just push it all the way through, and it's so easy for me to create holes on either side here. So the next thing I want to do is I want to create bosses here, which are basically like washers. So there's more than one way for me to do this. So I can maybe once again sketch it. So I can sketch concentric circles like this and push it out and pull it out and do it this way. But I actually have an easier way to do this. I'm going to use the plug option in Simplify and Patch. So what the plug option does is it automatically recognizes the holes in your model, and so when I say plug, it immediately creates plugs into your holes, and you see they're actually independent parts. So that's what the model browser is for. So it actually catalogs and displays a list of all the solids and the geometric entities you have in your model. And plug is an easy way to just fill up all your holes. So what I'm going to do is just create smaller circles and push them out so that I get a different component. I'm just going to click on these plugs. I'm going to change the color. So you see how I'm doing it. So I'm just clicking on the entity that I'm interested in, and it immediately lists all the details about it in the property editor, and I just can change the color from there. So I'm going to do the same thing here and here. So now there's actually a reason why I'm creating a different part for these bosses here, because this is actually a component in my design which I do not want modified. So optimization is basically removing material based on the load paths and making sure you have a stiff design, a stiff shape with very less material. And so you need to tell Inspire where it can remove material from and where not. And the other concept with optimization is you really need to separate your design space from spaces where you apply your loads. So components which are where you really apply your loads are always separated from the component that you actually optimize and remove material from.
Rahul, I'd like to interrupt for 1 second. Question was, is after you define the circle and you decided, that you want to change the diameter of that hole, can you still do that now?
No, you can't change the diameter of the solid once it's created. I'm afraid not. But you can very easily just recreate your circle or any shape that you're creating. So I'm just gonna.
Yeah, if you can show that to us, because is that because you already made the boss in there, or?
Yeah. So once it's a solid, I mean, you can edit your solid. So the way you can edit your solid is you combine solids together, you cut them up, or you do certain Boolean operations like subtract a solid from a solid, but you can't really change the dimensions of the solid very easily, except when you're pushing and pulling, which you can still do. So you can still do some of them, but you can't really change the diameter of the cylinder, for example.
Okay, so you have to, so again, can you explain the process of, let's say you realize now you need to change it? Maybe change the front one?
Okay. So I guess, so you'll just have to maybe redo, just create another sketch, and for example, I'm just going to increase the dimension of the circle here and just remove that. Unfortunately, I'll have to delete this and then just create a quick sketch this way and create your new boss. It seems a bit because I mean we can imagine changing cylinders in our mind, but it just doesn't work that way with Inspire. So you still have to redo your sketch. I hope that answers his question.
Yeah, but if you would have, again, the point is when it was still in the sketch mode, you could have changed it, but once it went into solid, then it's permanent at the moment. So that's what you're saying, right?
Right.
Okay.
You can change the solids. I mean, you can still push and pull. So there are certain dimensions of the solid that you're changing. For example, the height in this case, or I can actually push and pull any surface. So this is really all I need, but I guess it's always interesting to think to think about improvements, and maybe we're going to have a feature which will help us change the diameter of a cylinder, but that's just not possible right now.
Okay, great. Yeah, you answered the question.
Okay. Yeah. So I'm just gonna now rename this to maybe boss one. So just to let you know that it's very easy to rename your parts so you know what parts are where. And so I just right click and rename. It's very similar to your Windows in that sense. So I could actually close the property editor because it's giving me a lot of details that I don't really need right now. But almost everything I need done, I can right click on my part and I have a context menu that tells me, that gives me all the options uh, necessary to change it or organize it. So this is my model and I'm done with the geometry side of it. So the next thing I would want to do is assign a material. So with Inspire, it's you either use a material from the material library, which is uh, good for most purposes. But if you have a material that's not listed in the library, you just go to My Materials and enter the material data, and in this way, there's really no material that you cannot use for your design. So these are the materials available in the library, and you can uh, also add materials here, but I would actually assign the material by using the context menu in the graphics area in the workspace. So I just right click on my part or solid and just choose the material that I want to use. And the materials we create are also listed here, like material 1, which I just created. So I'm going to leave this at steel, and I'm going to choose steel for the bosses as well. That's the default material, and I'm not going to change it, but that's how you change it. And you can also do it here in your model browser. So we really need to decide which component is going to be optimized, and that's again easily done using your context menu in the workspace. So I just right click on the component that I want optimized, where I want material to be removed and made stiffer. So I just right click, choose that as my design space, and you see it immediately changes color to indicate that this is now a design space. This is a default color that indicates a particular part is a design space, and Inspire is going to work on it. And if the color doesn't change, if it's what you already had assigned, it's not a design space, and Inspire is not going to touch that, and this particular boss is going to remain the same throughout your design. So if you're wondering how I'm going back from moving a part, for example, I'm just using Control Z on my keyboard and getting back to where I was. So that's about the materials and choosing the design space. So the next thing I want to do is I want to make sure the concept generated by Inspire is actually symmetric across certain planes. I can do that using shape controls. So this is kind of, there is a trick to using the icons in Inspire, because you actually see this is actually a set of icons in this case, where when I click on this red rectangle here, I'm actually choosing the symmetry options. But if I choose the blue one here, I'm choosing the shape controls or the manufacturing constraints. So in shape controls, I choose the symmetry options, and I'm choosing the general symmetric option because I don't really need a cyclic symmetric option here. But a cyclic symmetric is something you would use, for example, when you're designing the alloy wheels of a wheel, and you would say, I want a 6-sided symmetric design, and then your wheel will be symmetric with spokes, with 6 spokes of a particular shape. And so that's an example for which you would use cyclic symmetric. So I'm going to use symmetry options, and once I've chosen the general symmetric option, now all I have to do is click on the part that I'm going to optimize, and it immediately creates 3 symmetric planes which are highlighted in red here, and I just have to choose the ones I don't want. And again, I just right click outside, and I'm now done with that function. So you see there are these 2 transparent red rectangles that basically are telling me that shape controls have been applied, symmetric controls have been applied, and the optimized design is going to be symmetric in your XY plane and your XZ plane. Now, these rectangles are actually a bit distracting for me, so I'm just going to hide it. So the way I did it was I just click on the icon to the left of the entity. So as soon as I created a shape control, the model browser lists it as something that's been created, and I can just hide it using the icon there, or I can do it by right click and hide as well. So now that's done, I want to also apply a single draw manufacturing constraint. Basically what I'm saying with this is I'm going to be casting this part, and I'm going to have a single draw method of removing my molds. I'm just going to press this icon here to say this is the direction I'm going to be removing the mold from, and it creates a shape control in this way, and now Inspire recognizes that I want to cast it, and then the optimized shape should be removable, should be of such a shape that the mold is removed and can be removed in the negative Z direction this way. So that's about manufacturing controls, and the next thing I want to do is apply supports and forces. So here I'm just going to start with applying a support. I'm going to apply support here. So you can apply supports on surfaces this way, or if you have a bus or a hole like this, so I'm just going to select it, and it immediately creates a support which is actually restricting the movement of this entire component. And when I double click on it, I can then release degrees of freedom this way. I'm basically saying it can now rotate and translate, but in my case, I don't want it to rotate or translate. So I'm just going to double click and click on these arrows and turn them transparent from green, which means I don't want them to rotate at all. So it's completely fixed at that end. What I'm going to do now is apply forces here. I'm just going to zoom in to show you what's happening. So I'm selecting the inner cylinder this way, and it's immediately creating a force. And I don't really understand pound force when it comes to forces, so I'm just going to change my unit system to newtons, and I'm going to say 1 Newton. I'm going to do the same here. So you see, Inspire immediately created a load case which is basically the organizational entity which holds all your supports and forces. And I'm just going to hide these forces. I'm going to once again choose forces here and click on the circle again. So Inspire is really intelligent this way. It knows that I've already applied a force in the Y direction. Now it applies a force in the Z direction, in the X direction by itself. I'm just going to do it again. So you see that it now chooses to apply a force in the Z direction. So if I now show all the forces on my workspace, I actually have a force in all directions, which is what I want. So one of the most useful things with the load case idea is that I can create multiple load cases and then actually have more than one combination of forces applied on my model during my optimization. So what I'm going to do now is I'm going to create another load case. So I just right click on load case and I just say new load case and it creates another one. I actually need 3 load cases, so I'm going to create another one. So it's really as easy as dragging. So I just highlighted 2 of the forces and I'm just dragging them into different load cases. So I just pull it into load case 4. So let me just show all the load cases so I know what's happening. So I have both the X forces in one load case and I have both the Y forces in the other load case. So this is exactly what I want. So I can actually now run my optimization with different combinations of loads. And I realized that I need a support for every load case, and I've created only one. So I can either go ahead and create some more supports, but I can also just copy the support. I actually cut it there. So what I wanted to do was I want to copy the support, and I'm just gonna paste it in each load case. So now what happens is I have a support for every load case, and I don't have to recreate it. I just have to copy it and paste it. So we are now ready to run our optimization, and we're going to do just that. And what I want to do is I want to maximize stiffness. That's my objective, but I could also minimize mass. So my idea is to maximize stiffness, but I also want to tell Inspire what should be my mass target. So I could give a mass target in terms of total mass. I could say the mass of the final shape should be so many kgs, or I can specify in terms of design spaces and say this should be the mass target for this particular part, or I could give it as a percentage of the total design space volume, which is what I'm going to do here because I have just one part. So when I say my mass target is 30%, I'm saying you can remove Inspire. I'm telling Inspire it can remove 70% of the mass while it maximizes stiffness. So as with any optimization run, you can always give constraints. You can give constraints in terms of frequency, saying the optimized shape cannot vibrate in certain frequencies, which you can input here. Or you could give a thickness constraint. I'm just going to go back to the inches system for this. And I'm going to say 0.6. So basically I'm saying um, every kind of wall or a membrane in the optimized shape should not be less than 0.6 inches. I can also apply a gravity load, which I'm not doing, and here I can actually choose the combination of load cases that I'm applying on the run, and I can say load case 2 and 4 or all 3 or just load case 2. It's really up to me, and it's very easy for me to run combinations of runs. So I'm just going to run this particular optimization run, and it really shouldn't take long to see the results. So while it's doing that, I actually will be detailing the solid edit and the simplify patch tools using a different model, and what we can do with the optimized shape, as I'll be showing to you in a minute, is once we get a concept from Inspire, we can immediately analyze it for performance within Inspire, and that's what the analyze option is for. So you just say, just use the existing loads, because those are the loads that the component is going to function under, and quickly tell me what the stresses are going to be. And if you see the stresses are way too low, I would always go back and try and run it with maybe a 20% mass target, saying, all right, you can remove 80% of the mass, so that we still have a very stiff component, but we're removing more mass. So this is the run status window, and it's actually telling us what's happening with the status, and I can actually view the status in detail. So I just click on that and say view now, and it's telling me that it's 7% completed the run. So while it's doing that, we can actually take a look at the measure tool. So I am right now using the measure length option, and I just have to keep it at any particular edge, and it's going to give me the length of that particular edge. I can measure the angle, and I can measure the weight. What I've actually done here is I have displayed the mass for the components in the preferences. So because I've done that, I don't have to measure the mass of the part using measure option here. So when you go to edit preferences, you go to mass calculation and say on, so you have a good idea of the mass of each part in your model already. One really cool thing with Inspire is that it's a part of the HyperWorks suite of software, and HyperWorks users can easily just use Inspire the same way they use HyperMesh. When it comes to panning and rotating your model, all you have to say is HyperWorks compatibility and say HyperWorks tail rotation and pan on, and you can then run your rotate and pan your model as you would HyperMesh. So we're going to just let this one run, and I've actually got a model that I ran before with multiple options with varying thickness constraints and varying load case combinations, so that we can see the different concepts generated. So while it's running, I just want to ask Darius, I think we're kind of going to go over time, and I guess we're going to let people ask questions in after this time.
Well, I was going to suggest while it's running, this is a great time to ask if anybody has any additional questions they would like to be answered about Inspire. So if feel free to type in the question window if you have one, and I will let Rahul know what questions you have. And just want to let you know, for the student version of HyperWorks, it includes all our major packages. So Inspire is one of the packages that you'll get when you get the download for our free student version. You also get products for HyperMesh, HyperView, OptiStruct, Radios, and so forth. Those tools have a 10,000 node limit, and Inspire does not have a 10,000 node limit. And so it's more just limited on how much memory and this and the just capacity of your computer you're running it on at that point. So if you do get the version, student version, you can run pretty good sized models on your workstation. All right, so I do not see any questions, and it looks like I think your model has finished. So why don't you show the results, and then after that we'll go over the couple polling questions.
All right, so the run is done, and you see a green flag up here which tells me that everything's fine. And I just have to click on my run, because we usually have multiple runs running in this window, and you just click on the run that you just completed and say view now, and this will give you the concept, the design concept. And Inspire now has calculated that this is the best shape given my constraints. So as soon as the run is completed, I actually get a small window which allows me to change the density to see what my design shape would have looked like if I had given a different thickness constraint. So I had given a thickness constraint of 0.6 and also 30% mass target, and that has kept the design in this particular configuration, but I can change it. So I can very quickly, I think this is a density that I'm very comfortable with, and I think this is a good shape for me, for my design, and I know that it weighs much lesser. So if I actually see the initial component weighed around 40 pounds, but the design generated by Inspire weighs just 16 pounds. And I can quickly run an analysis and see if it'll see what the displacements and the results, the other results are going to be mainly factor of safety and one miser stress. I don't think this is going to take long, so I'm not going to let Darius ask his poll questions yet. So yeah, so we're already done, and so you see I'm just plotting my displacement result. So it's been contoured in this way. You have various ways of contouring, and you can change your legend colors, etc. And you can animate your model, and you can control the speed of your animation. Just everything you need to post-process your analysis. So I'm right now quite comfortable with this design. So what I would do in that case is I'm gonna fit surfaces. So when I fit a surface, what Inspire will do is actually generate a solid shape out of this design, which I can then export to any CAD format. Just about every format that we were importing the files from into Inspire, we can export, and we can then use that as a template to create the final design. I think, yeah, there is. I think it's time.
I just wanted to mention that with the animations that were going on with the displacement, again, those were exaggerated movements just to show how it would move. So the actual values was shown on the legend there, but but the animations are meant to give you an exaggerated movement. So I wasn't moving that far perspectively to the model.
Exactly. And you can actually, as I showed, change the animation speed and also the scale of animation, as we call it, the scale of deformation, to make it seem more realistic and give you a good idea of how much it's deforming. And what we're seeing here is actually a solid shape generated. So I worked on this model earlier, so I'm just gonna clear the space and I'm gonna open up one of the concept that you just saw. So I just took it to a CAD tool and fine-tuned it to look like this, and this will go into manufacturing for me. So that's about the design process, and I think we will ask you to ask your questions now.
Okay.
And if you still have time, I think maybe 10 or 15 more minutes, and I can show you a lot more.
Okay. Yeah, so we have a couple questions that came in. So the first one was, can I export the optimized design to a step file and then open it in another CAD package?
Yes, exactly. We can. So once again, I'm just going to double click on this particular optimized shape, and I would say fit. I'm sorry, this is actually an older version of the model. So I would actually fit surfaces on this, and once I'm done, like I showed earlier, I could actually save this to step or parasolid or IGES, just all the formats that you would require to save it into.
Okay, great. The second question is, can the meshing that was generated to optimize this design be preserved and opened in a hypermesh?
Yes, you can. I mean, there's more than one way to do it, but the main way would be to export. So once you've got everything set up, you just click on export, and it exports a .fem file into your run directory, which you can then import into hypermesh and immediately solve an OptiStruct, because it's going to have the material definition, the loads, everything.
So what you're also saying is that the run that you're doing is stored in on their local drive, and then they can then access those files there. So can you just show where those files are located, the run?
Right. So you can actually choose the run directory, which is usually in my documents in my case. So in edit and preferences, I've got this option here to specify a run history path. So I just have to go there.
And that's where you would also modify it too if you want something different, correct?
Right. I just have to look at it again where it is. So it's an temp.
Yeah, I think that is your just my local directory that you have set up. But what it does, it makes a separate directory for each run you might do. But Yeah, I would normally suggest not to leave it in the default. Put it in your C drive someplace where it's a little more accessible at that point in time. And then inside that run directory, as Rahul was saying, there will be a .fem file, which again is the OptiStruct based file, and you can read that into HyperMesh and then continue on if you want to do something else with it. Just because we are short on time, I'm going to move on to the next question here.
Mm-hmm. But I just got
okay.
I just got to the place, and yeah, so you're gonna find your H3D and your FEM files here.
Yep. Mm-hmm. Excellent. So not sure. This is the next question. Is they're asking is, are there different parts in the model automatically constrained? Fixed to each other. So
exactly, yeah, that's actually a good question, because yeah, you would wonder if this boss is automatically fixed to this one. Yes, they are. They're actually Inspire actually generates freeze contacts in certain cases between components, and there's always connectivity. They're connected completely. Yeah.
Okay, thanks. Excellent. Yes. So the next, I have a general question. Are there also additional tutorials on the Altair University site for Inspire?
Yeah, we've got tutorials. There are some which could be, I think, which would be very interesting to, I think, FSAE students especially. So I'm just going to the training center. It's just training.altairuniversity.com. I'm going to search by discipline and go to the Inspire section. So we've got a lot of video series and etc. here, but you've actually got a pretty interesting tutorial here about a steering wheel that can be designed using Inspire, and you've got pretty cool designs. Certain other tutorials here.
Excellent. Yeah. So the key thing is I wanted to get at was there's more than one tutorial. There's multiple other tutorials for people to look at there. So fantastic. Good, good. So a couple more questions came in. We'll see if we get to those. Is Inspire just a CAD environment talking to HyperWorks and HyperWorks doing the analysis? That's the question.
Well, Inspire is actually a standalone tool, so it's got everything within it's got everything contained within itself to do everything Inspire does. So it's not just a user interface talking with HyperWorks, yeah, but it is a standalone tool. Yeah.
Correct. The background, though, the tools that's built into Inspired is OptiStruct, both for analysis and optimization. But if you were to install just Inspired by itself on a separate computer someplace else without any other HyperWorks products, it's a standalone product. So I'm pretty sure that's the question you wanted to ask. The next question, is there any tool for smoothing the surface of the optimized shape?
Well, the tool is called OS Smooth, and I think perhaps HyperWorks users would be familiar with OS Smooth, but we are actually already smoothing it, and it's not gonna get to the final design that I showed. There isn't any smoothing algorithm that's going to do that, except a human being with the clear idea of what he wants. And I wouldn't directly just smooth it and use it, because in any design, I mean, I'm right now just removing mass and making it stiffer, but then I also have to take other design considerations like aerodynamics. I need to put in holes for lubrication, and there isn't a smoothing software that can do that. So I am going to smooth it myself. But yeah.
Yeah, and kind of just we're kind of jumping ahead, and I normally don't like talking about future releases, but our next version of Inspired coming out later this year will have the capability of defining NURB surfaces in the method you want on top of your part that Inspired has there, and that you can basically push and pull and get it to do a lot of that without going to an outside CAD package, and so that will allow you to do a little bit of smoothing. But the key point is it's only to a certain degree. That's what you're kind of saying there. You want to go so far without getting human intelligence involved.
Exactly.
So, great, great. Are there only isotropic materials applicable in Inspire? Is the next question.
Right. So that's again the current limitation. You're gonna be able to use only isotropic materials right now.
Okay. Do you know if that's coming in any future release to have that enhanced?
Well, no, I can't really say. I mean, I have to check.
Okay.
But that's something he can check with us on email, and I can reply with.
Yeah, use the support forum on the academia site, and then that will allow you
Yeah.
to also check into some more perfect. Yeah, that's good use case of that support forum there too. Excellent. I know we ran really long, and we've lost a few people since then, but we'll still do the polling questions right now. And again, I'd like to thank Rahul for doing a fantastic job and showing some of the capabilities Inspire. There is, many other possibilities you can use it with. Please check out the tutorials, and then as you do have questions, use the support form that we have there. So we're starting the polling questions. The first one is, would you like a member of our team to follow up with you to do further trainings? What this means is for, again, your team or your department to have us to do maybe a little bit more focused and detailed training. Our typical training of Inspired is about 4+ hours, not too much more than 4 hours, where we go over each functionality in more detail at that point, so you can even use it with more confidence. So if you'd like us to contact you, please indicate yes. If not, hit no. Again, all right, so just a couple more seconds and we'll go to the next one. Thank you. So next question is, the next question that we have is, what month would be the best for training webinars for the Formula teams? We did these right now because we had time, and we know it's kind of late, and for the Formula teams, your car is pretty much already done. You're probably only doing final tune-ups to get it on the track. So you can't do any additional analysis at this point. So we would like to know when it would be best for us to provide these type of seminars and other seminars for you. So if you can indicate what month works best for your team for your next build cycle, that would be great. And January, February and March, April would be of next year. May, June, July would be for this year. Excellent. So that's done. There was another question, the cost of training. Any training cost is actually, it's a regional based. So if you were to contact a team, so let's say if you're in UK, they would work with you on that. If we can, for universities, EDU type of teams, we typically, if we can, have very reduced cost, and even cases free, but that is the final decision of the local office there. So I can't really answer that question exactly, but even if we was a cost for EDUs, it's less than our normal commercial cost at that point. We've done it before, where we've done web-based trainings, like 2 hours at a time, and then we would do it that way. And our office here, we've done that at no charge. So, I mean, there was maybe, Rahul, you might know the answer to this question. Is it possible to create user-developed routines within Inspired? I don't think there is, but do you know if there is?
Well, it's not really customizable as a hypermesh is. That's what I'd say. But then again, use a support forum, and I can give complete answers to such questions.
Yeah, because right now I think probably the routines that they're looking for are optimization. But yeah, we'll need a little bit more detail. What type of routines are you trying to have it access at that point? So great. Thank you, everybody, so much for your time. We did run long, and we're able to keep a decent amount of you till that time, so that means that you're interested. So thank you so much, and have a great day, and we'll be in contact with any of the teams that wanted us to reach out to them. Thank you again, everybody.